Hello, thanks for joining us today. We're here coming to you live from the studio at Jackson Systems. Usually we're in our training room, but tonight we decided to have it be a little bit more of an intimate affair, Joe.
Nice.
So we're doing it in our studio. Couple of things just to get us going, and that is, for those of you that have joined us online, thank you very much. We really appreciate it. If you have any issues or any questions, please type those directly into your web browser that you're watching us on, and we will be happy to answer those. But also know that we have a Q&A session afterwards that we'll be happy to answer multiple questions if there are any. And then lastly, we always record these. We will make sure that it is posted usually the next day, but definitely by the next Monday for sure. And they'll be posted so you can watch them, share them with your fellow coworkers, whatnot. So we're making sure that you can utilize this training and pass it on if you need to.
Sounds good.
All right. So first and foremost, my name is Mike Lee. I'm with Specified Controls, which is the commercial division of Jackson Systems, specifically the manufacturer of the HVAC controls, and also the manufacturer of gas detection that we provide. Joe Jackson here with us. Joe is the Vice President of Custom Controls at Jackson Systems. Is that correct?
That's correct.
Okay, got it right. And Joe is, he's Mr. Know All About This, is the easiest way I can put it. Joe's our go-to guy here at Jackson Systems about gas detection and all things custom control related. So we got the expert here who's probably done, what would you say, a couple hundred gas detection jobs over the years?
At least.
Okay, so you got a guy who acts like he knows what he's talking about and a guy who does actually know what he's talking about. Is basically what we're talking about. Okay, so first and foremost, we want to talk about gas detection from a simple standpoint of application and where gas detection fits in, okay? So we'll start out by talking about the different types of gas detection jobs you might come across, or that at a design build situation, you might just need to be thinking about the fact that you need gas detection in those types of applications. So first and foremost, obviously a parking structure is one of the most important and largest gas detection jobs you're going to come across.
Here in Indianapolis, they're building a lot of urban multi-story apartment complexes with parking garages underneath. And not only here in Indianapolis, but across the country. We've seen a huge amount in Texas, Florida, those places. And sometimes it's only 20 or 40 parking places, but sometimes it's 250 parking places. And those, if they're underground and they have to have ventilation, then almost always a gas detection system is required.
And I would add to that, a lot of times these are actually above ground, but the apartments surround the garage. So there is no actual natural ventilation occurring, so they have to have gas detection to meet code. So parking structures are a very big one. Warehouses, obviously anything that's going to have a propane forklift or fork trucks in it, but also a lot of warehouses where trucks will drive through, where vehicles will just drive through. We need gas detection.
And the thing about a warehouse, Mike, is that a brand new car doesn't put off a lot of fumes. A fork truck does. The EPA requirements on a new vehicle are pretty tight, so you still have to have gas detection, but if you drive a fork truck by a carbon monoxide sensor, it's going to go nuts.
Yeah. In fact, a couple of weeks ago here in our warehouse, we just had a handheld CO sensor started our fork truck, and I was about 15 feet away, and within about 5 seconds, it was reading 70 parts per million, which is alarm level CO. So absolutely, definitely one of those things. Car dealerships, without question, every car dealership we ever see is going to have gas detection on it.
In the service space.
In the service space, not within the actual sales floor. Cars aren't supposed to be running in there anyway, but anywhere that they're going to have a vehicle running, they're going to have gas detection. Auto service body shops, anything like that. Municipal buildings, want to make sure that we clarify, when we say municipal buildings, we're talking about police department, fire department, garages where they're housing snow plows.
Department of Transportation.
Right, things like that. Anytime there's a garage, basically, is what we're talking about there. Grow houses. We'll talk a little bit about this later, but exactly what you think I'm talking about when we talk about grow houses. They are popping up throughout the country.
Haven't seen any here in Indiana though.
because it's not legal yet.
Oh, okay.
But it's the devil's lettuce, as some people refer to it. But yes, it is very important, gas detection in grow houses, and not just marijuana, but also strawberries and fruits and vegetables and things that are grown indoors. We're finding more and more of this, and CO2 management becomes very, very important in a grow house. And then anything where oxygen is displaced is where we need gas detection. It's all kinds of different applications where you might not even think about it, but gas detection is needed. So,
well, definitely in a mechanical room with a large quantity of refrigerant.
right, absolutely. Okay, so real quick, a couple of quick notes. Electric cars, when you are charging the batteries on electric cars or on fork trucks, it creates hydrogen. A lot of people don't realize that, especially a lot of engineers, but it is something that happens and is something that we need to be mindful of, as hydrogen is extremely explosive. Diesel creates NO2. That is another thing that we need to be mindful of, and NO2 is extremely toxic. Recent report that the EPA did talked about the carcinogenic level and also just the toxicity level of NO2 being 100 to 200 times that of CO. So it's very...
It's the nasty stuff.
It's very nasty. It's very, very nasty. And then CO2 is not measured in parking garages. I threw that in here just to make sure that we clarified. If you see CO2 on a set of plans in a parking garage, they don't want CO2. They want CO. They just use the
wrong term,
the wrong letters to describe it. CO2 is obviously carbon dioxide.
People give off.
We give that off, not cars. So we just need to keep that in mind. And then large electric magnets, anything that's an electrical magnet in most cases is going to be cooled by helium gas. And so we need to, in a lot of cases, when we have a large magnet involved, we would need to put a helium sensor on there so that we make sure there's no leak, because the electric magnet could fry out and then we got a couple $100,000 worth of damage to the magnet itself.
Where do you see big magnets at, Mike?
Typically in an MRI room is where you're going to see those. Okay, so quick question for those of you online. The guys here in the room, you already know this. I know you know this because I can tell that you are definitively knowledgeable on this. Which is more deadly, CO, CO2, or NO2? Alex, we got anybody? So nobody's going to take a crack at it.
Go ahead and tell us.
What I'm going to tell you is NO2, by far, is the most deadly fume or gas that we're going to deal with of those listed. NO2 is measured in parts per billion, not in parts per million. So it is extremely toxic, and we need to evacuate the air or the fumes as quickly as possible in that situation. Very nasty stuff. Okay. All right. So let's start by talking about code requirements. Why do we want to detect the presence of toxic or combustible or explosive gas? It's all about safety is really what we're talking about here. The owner must provide a safe breathing environment for anyone in their building. It's just simple safety, and also code dictates it. So when we're talking about code requirements, there's all kinds of local, there's all kinds of state codes. ASHRAE has code.
Universal Building Code.
We'll talk about in a second. There's several codes, but the reality is, and the simplicity of it is, the owner has to provide a safe breathing environment, right? Also, economics play into this. So economics are from the standpoint of changeovers per hour, what we need to do to make sure that air is clean. As far as our fans go, how can we make those more efficient? How can we design it so that we're not running a 50,000 CFM fan all day, every day? Depending upon the climate, the economics of this can be expensive. If it's a below ground, or that's probably not a good example. If it's an above ground parking garage in Texas, it's going to get hot in there, right? Mm-hmm. So they're going to want to run the exhaust fans to try to cycle air through there. Well, Are they doing that enough? Are they not doing that enough to ventilate it? Those kind of things. So there's a lot of different pieces to this. And then continually running large fans, as we say there, is very costly. Obviously, it's a cost. And then warning the public is probably the most important one, and that is literally the liability of this. You're taking on a great deal of liability as the owner of a building if you have a parking garage and you don't put in a gas detection system.
You pretty much have to run the fans, and then you still need something to
Right.
notify something if a fan fails or whatever.
Right. Yep. So there are economics, but the key and the most important thing to this is this is life safety, without question. Not a whole lot different than a smoke evac situation. You're dealing with toxic fumes. Okay. What does ASHRAE say? For those of you that don't know what ASHRAE is, it is the American Engineering Association, basically, is what we're dealing with here. ASHRAE says all this stuff. Here's what they really say. You can read all that, or you can just go with this. ASHRAE essentially says use gas detection in any parking garage. That's the gist. Okay, and I haven't seen a parking garage lately that didn't have gas detection of some sort on it, in some part of it.
That's true.
Right?
If it doesn't have natural ventilation.
Right. Okay. So as far as building codes go, specific building codes that you want to take a look at, International Mechanical Code, Section 4035 about public garages is one that you want to look at. And it specifically calls out 25 parts per million as the alarm level for CO. It currently does not talk about NO2, but I am told that this year it will be adding that. So there will be a parts per million of NO2, which will probably be 0.1 parts per million is what it'll be, so 1 part per billion. Uniform Building Code Section 705 also talks about parking structures and CO2 and how, a CO and how it should, see I just did it, CO should be monitored, and they have a little bit different parts per million requirement. So they're talking about 50 parts per million during an 8-hour period is what's considered acceptable. And so they would alarm at 50, and then at 200 would be a max level that it could ever be at. So they have a little bit different code to that, but most engineers will cite the International Mechanical Code as the alarm level that they want.
And for us here, if the engineer doesn't specify something, we always just go with 25 parts per million and make things safe.
Right, exactly. It's always better to get that air clean than it is to mess around with it.
And with all these different numbers, even OSHA has another standard.
Yeah.
So lots of different people have lots of opinions, but 25 parts per million is definitely the safe level, and that's what we go with unless somebody directs us otherwise.
Okay, and I just found out that I have a question. Let's see here. So what about gas detection in apartment complexes? Donald, if you can hear me, please clarify what you mean. Are you talking about in a parking garage, or are you talking about inside the actual apartment itself? So get back to me, and I'll answer that question for you here shortly. Okay. As far as this last little note on your screen, I just want to point this out. Codes are continually changing, especially state and local codes. So always refer back to state and local codes. As an example. There are certain states now that have banned gas detection sensors where NO2 and CO are in the same sensor at the same height. They have to be able to put the NO2 higher or lower than the CO. So it just depends on what state you're in or what local municipality rules that you have in terms of code. So always make sure to check that. The other side of that too is ASHRAE is always updating their code suggestions, which states will then implement. One of those that's coming, I can tell you, is, as I understand it, is that right now code for CO2, clarifying carbon dioxide, is 2,000 parts per million is the highest level. They're about to lower that to 1,000 parts per million, which most people already do, but it is going to change a lot of design where you have to have a larger fan or a fan that runs more often to make sure that you're under 1,000 parts per million on that. So, Okay, Donald, you got back to me. Thank you very much. So inside the apartment itself, it really boils down to local code on that. As an example, in New Jersey, it is now code that any living structure above or in any any structure, it's not even living, any structure where people would be in the building that is 2 stories above the parking garage, those 2 stories must have the same gas detection as the parking garage. So it just depends on the local code. So I'll give you an example. In New Jersey, you got a parking garage that's below grade. You have apartments on the 1st and 2nd floor. You would have to have the same gas detection sensors in the 1st and 2nd floor in every single apartment. If they were all retail spaces, then you'd have to have one in every store. So it just depends on that local code. Now, if you're talking about CO2 management in the apartments, that's a little bit different. And that is not going to be the exact product we're talking about here today. That's going to be a simple, I'll be honest with you, you can use a Honeywell or a
ACI.
There's several sensors out there. A lot of thermostats actually now have CO2 in them that you can use. So it just depends on that. I hope that answers your questions on that.
Just to touch on a couple of little things, monitoring CO2 in a home or an apartment is great, but you have to have a way to get it fresh air in there. If you're going to, monitor it, you need to have a ventilation system. And Jackson Systems can help you out with that too. We have a couple of different ventilation systems, some outside air dampers for even residential size furnaces. Right. So if you need help with that specifically, we can help with residential ventilation as well.
Your salesman that you deal with can help you with that, no problem. Donald, if I didn't answer that, chime back in and we'll clarify for you. Second question we got are there any requirements for banks that I am aware of as far as a national standard? No. There certainly might be local codes. I can see where there might be oxygen deprivation sensors, as an example, in a vault. I don't know.
Yeah, I've never heard that. All the vaults that I've had have some sort of small fresh air
intake.
Yeah.
So I don't know of any in a bank.
I've never personally installed any in a bank.
Right.
It's almost always been something automobile or truck or forklift or something related.
Something is generating this gas.
Some engine running someplace.
Right. Something is doing. The other
or
thing.
Battery chargers.
The other thing we've seen too is oxygen deprivation because they're using liquid nitrogen as an example. So there's a gas that's being introduced or a liquid that's going to create a gas that's being introduced to the space. And so we have to make sure that the oxygen levels are high enough so that nobody passes out. That's common. Yes, sir.
Is NO2 heavier or lighter than air?
This is a very
Great
good question. Very good question. The question was, is NO2 heavier or lighter than air?
That's probably the number one question we get.
It's a 2-part answer. Okay? So the real answer is this. When NO2 leaves, when diesel fumes leave an engine, they're superheated. So they rise. And then as they cool off, it becomes heavier than air and it falls. So to answer that question and to get to where I think you want to go, you're talking about sensor height and where it should go. We're going to get to that, Rand, shortly.
You were talking about that one right there, and that's what I kept thinking about.
Sure, absolutely.
Still carbon monoxide, is
Right.
heavier.
Yep.
It goes across the floor.
Right.
And sensor height is probably the most asked question we get.
Sure.
And if you look at it on the internet, there's 6 different answers from 6 different people, and it's
We have a
tough.
pretty simple concept. We'll show you some drawings and everything here shortly. Okay, so let's move on here. So, should gas detection be used in grow houses? I already answered that one, but I'm going to see it out there in the interwebs if anybody has anything to throw up there. While we're doing that, also, Jacob, you've asked, what are the limits for helium in hospitals, and should the full air handler be monitored or just the room? In fact, I can answer that real quickly while you guys are thinking about grow houses. The helium, it's a very small amount of helium that is inside the MRI machine itself. And because we're inside of an electrical field, we can't have anything metal inside the room. So the sensor itself can't even be in the room. It actually needs to be outside of the copper mesh barrier. And then you would actually use a duct mount adapter for this. And then you would literally run a tube right down next to the MRI machine. And all you're doing is looking for any sense of helium, and that means we have a leak. And you put it right above the MRI machine.
Helium's lighter than air?
It is. That's what I've heard.
Okay.
So to answer your question, it is a very small amount of helium, and all we're looking for is there a leak in the MRI machine itself? Because if there is, that can fry the entire machine, and that's I'm told between $400,000 and $1 million machine, $400,000 and $1 million machine. So we just want to offer a way to make sure it doesn't fail. So no worries about helium itself throughout the whole hospital. It's just in that specific area. Now, hospital-wise, other gases, without question, there's other opportunities there for gas detection as far as a contractor goes. But as far as a safety measure, in most cases, hospitals will have some specific sensors in specific areas, and then they'll have a mobile cart, kind of a handheld thing that they'll walk around with and use in hospitals. So there's not as much gas detection. Still, the parking garage.
CO2 would be the other big thing.
CO2.
Lots of
fresh
people.
air. Lots of fresh air. Yep. Okay. All right. So we're moving on. Grow houses. Absolutely. One of the largest growth opportunities for gas detection is grow houses. CO2 management in particular, but also there are other things. We just learned this a couple months ago. But in grow houses, in particular grow houses, they use ethyl alcohol or other alcohol-based liquids to clean the plants because it evaporates and it doesn't take any oils or anything else with it. And so that makes perfect sense, except for the fact that now you're in an environment that is specifically designed to have ethyl alcohol evaporate into the air. And you're going to have exceeding amounts of ethanol in the air. So you need vapor hoods, you need all these things, but you need specific infrared ethanol sensors to make sure that there's a safe environment, because the level of LEL, the lower explosion level of ethanol, is pretty high. You have to have a lot of it in the air, but the breathing level, the safe breathing level of it is extremely low. So you can't use an LEL sensor in terms of what we would normally use for this to make sure we don't explode. You have to use an actual infrared sensor that can tell you the exact part per million so that you can be in a safe breathing environment so that the people working don't have to actually wear scuba gear while doing it.
So you almost need two sensors.
Right. So there's a lot of different things that go into a grow house, but we're happy to help with any situation like that, where we can look at the plans and even talk to the engineer if we need to about what's needed. Okay? All right. And then David Colton has asked, what liability do I have if a helium sensor fails on a $1 million MRI machine? That is a good question. What I would say to that is, in a case where you would do that, what I would suggest, and Joe, you can tell me if I'm wrong here, is that this panel should be, or this sensor should be linked into or communicating with an alarm system of some sort, so that it is known if the sensor fails. And our sensors would tell us if it's failed, so that you could know right away to switch it out or change it out.
And with any gas detection where it's life safety or $1 million are involved, it needs regular service and testing. We can talk a little bit more about that as time goes on here,
Sure.
but whether it's just carbon monoxide in a parking garage or helium for an MRI machine, it has to be checked on a regular basis. So while our sensors are really reliable, it's electromechanical.
Right.
It can fail.
And the other thing I would add to that is, I've been told this, a lot of the MRI machines have a pressure sensor on them. They have like a Schrader valve kind of a sensor on it to know if the pressure has been lost, but those fail too. I always looked at this as a backup for that. And the last backup, of course, would be the person working if they start talking really funny. That would tell us too that we have a helium leak. But the liability side of it, I can't give you a definitive answer. What I can tell you is, this is a alarming situation that we would just be providing for the hospital in terms of making sure that we're doing everything we can to help them with that. From a liability standpoint, I would think, I am not a lawyer, that the MRI machine manufacturer would be the one that would have to fix this if it failed.
we're just there to let them know there's a leak. We're
Right.
not, if their equipment fails, we can't be responsible for that.
Correct.
But whether it's that or life safety in a garage, either one, the equipment has to be tested on a regular basis.
Right, correct. And life-wise on these sensors that we're going to talk about, 2 to 5 years
Yep.
is typically the life of a sensor. So, you got to change them. You do.
You don't have to change the whole sensor.
Right,
but
just the
there's
just the
a
sniffer as we
plug-in board
call
in the
it.
back. Just swap it out every 2 to 5 years, and they tell you when they fail.
Right, yep.
But anything that's over 5 years old ought to just automatically be replaced.
exactly.
Just the sensor inside.
Okay, so we'll move on here. Just a quick answer to the grow house thing. The more light that is inside the building on the plants, the more CO2 is needed. The more CO2 and light, the higher the yield. So CO2 management is really about making sure that we can grow things faster, because the more CO2 that's in there and the more light that's given to those plants, then they will photosynthesize more. So controlling CO2 becomes very vitally important, especially when you're growing something that is known as weed. Okay. All right. So carbon dioxide, nitrogen dioxide, toxicity levels, and related health symptoms. So levels of CO2 and NO2 in garage vary depending upon several things, mostly about how many cars can be in that facility, or in that parking structure, or in that mechanic's garage, whatever it might be, at the same time. How far does each have to travel? Now, in a car dealership, that's not that big of a deal. Short trip. In a parking garage that is 9 levels, they might have to drive 2 miles to get to the top, depending upon how big it is. If you've ever been to Universal Studios in Orlando, good Lord, you could drive for an hour to get to a parking spot, and it's within a quarter mile. The garage is not that huge, but it just takes forever. So the distance you have to drive can be of very big importance. The emission rate of the vehicles Joe alluded to earlier. Newer vehicles, you can back up a new Chevy Cruze to one of these, and it won't go off.
So we were doing a garage over at IUPUI, and I backed my 2016 Chevy Colorado up to one, stomped on the gas, and it barely budged. And a 78 Camaro drove by, and the thing went nuts. So the type of car does make a big difference. Mm-hmm. So if you're in a high-end apartment complex,
with a bunch of Teslas, you'll probably be all right.
Well, if it's a Tesla, you'll be all right. In Florida, you're not going to have a whole lot of emissions. If you're in an area where, college students are at, mm-hmm. and cars are less expensive and older, you're going to get a lot more emissions.
Exactly. And as far as diesels go, we can all say that they'll be efficient, but if you got a bunch of Volkswagens in there, you're probably in trouble.
Yep.
Right. So the diesel side of it is very difficult and very concerning in terms of that NO2. So just keep that in mind. I always make the joke with those of you in Texas. There's probably going to be more diesel trucks in Texas than there are in New York City. It's just the way it is. So keep that in mind. And then acceptable contaminant level within a given facility in terms of the sequence of operations. So keep in mind that there are acceptable levels that we can be at in terms of CO or NO2. Not really at NO2. CO for sure, CO2 levels, whatever that gas is. There are acceptable levels that OSHA and some of the other EPA and NIOSH, I think is NIOSH or however you say it. There's acceptable levels, but keep in mind, we're worried about the alarm levels and we're worried about the safety levels. There are, the EPA, as an example, says there are certain levels that are okay for a short period of time. Okay? All right. So this is just a chart just to kind of show you what the health hazards are, I guess I'd say, for CO and NO2. And what I want to point out is just that bottom one on CO and the bottom one on NO2. So you got 200 parts per million. You're going to have a slight headache. You're going to be tired and dizzy. With CO2, or sorry, with CO. I keep saying CO2. With CO. So, at 200 parts per million, you're not feeling great, but it's not going to kill you. Roll down. Look at the highest level of NO2. 5 parts per million. Chronic bronchitis and emphysema is immediate. That stuff you don't mess with. Okay? So diesel's bad. Okay? Let's just say that being locked in a garage with a car that's on unleaded gasoline, it's going to take a while. Locked in a garage with NO2 diesel engine is pretty quick. There's going to be sickness. Okay. All right. So, sequence of operation in terms of design in a building or a parking structure. The toxic gas alarm levels should be 1 or 2 stage alarm can be used. So you could alarm at, let's say, 25 and that's it. Or you could alarm at 25 and bring on a yellow strobe that says, hey, there's a little bit of a high level. And then at 200, you could put on a red alarm saying, get out of the building, right? So you can do either one of those. As far as fan selection goes, it's about it's dictated by the engineer. The engineer should provide that selection.
Fan sizing.
That should be done for you as a contractor. If there's questions about the fan, the one thing I'll point out, and Joe, if you have anything to add, please do. That is, there should always be, especially in an underground or enclosed parking garage, there should always be ventilation fans running at all times. And then there should be another large or multiple large fans to do the changeovers. However, you could also do those large fans running at low speed for ventilation and then ramp them up if need be. You can do either one of those.
We see a lot of fans, one big fan and a VFD on it. That fan runs at minimum speed all the time, and then when there's a gas detected, it slowly ramps it up to high speeds.
Right.
It's a really efficient way to do it.
Exactly. Strobes and horns should be used or should be considered for higher level concentrations. The one thing I'll point out is just the public in this situation. If they see a strobe going off, they think it's a fire. So we don't want to get everybody alarmed and freaking out. But if it's at a high level that's dangerous, we need to let them know. So a strobe and horn is something we should be considered. And then warning signs, which we'll talk again about in a minute. But warning signs, this is a strobe, as an example, that we would use. If that strobe is above the elevator in a parking garage and it just starts going off and nobody knows what it's about, they think it's the elevator, right? So a warning sign saying what that strobe is for is very important. And rarely is an engineer going to say, yeah, put a warning sign on there. It should be included in your price. It should be included in what you do. Just a plastic sign that says, warning, CO and NO2 levels high, please exit the facility. Will help with that process. Okay, so let's go on here. Mechanical ventilation considerations. 2 main factors are required to size the ventilation system: the number of cars in operation and the CO2 and emission quantities. There are various formulas for this. The engineer should take care of this. But just know that when we're deciding mechanically what we're going to do, we have to take into consideration those factors along with natural ventilation. If there's natural ventilation, we probably don't need it. But if there isn't, we've got to have it. Okay? All right. And here is let's see here. The teleprompter is so far away I can't even see it. Joe, can you see it?
Yeah, you're right.
No, I know what this is. It's the list of various safety organizations that and their alarm levels. So you can see here that there are varying alarm levels that exist depending upon who you're following. As we've mentioned, the EPA and ASHRAE. And
they're also behind you.
Oh, there we go.
Hard to read there too.
Yep.
Yeah, there's OSHA,
so Uniform Mechanical Code.
EPA.
Yep. So there's a lot of them there. Just know this very simply. You will always be safe at 25 parts per million of CO and 1 part per million of NO2. If you set those alarms, you'll always fit within those.
Almost every situation.
Almost every situation. Okay. Interlock the mechanical system with the toxic gas monitoring system. The CO2 monitoring system shall activate the mechanical ventilation by using either dry contacts to operate the dampers, louvers, fans, whatever it might be, or analog outputs to modulate. So either we're going to bring them all on, or we're going to modulate those various pieces. And it's done in multiple ways, but through a panel in most cases. Also, the sensor itself can do this if it's a small application. But we will determine the best way to do this. Usually the engineer will tell us, but oftentimes it's a design build, and we'll offer up the suggestion. CO2 and NO2 monitoring must be capable of activating both exhaust fans and air intake devices. The most important thing is what's in red there. Okay? Engineers, God love them, do this all the time. And that is they want to use a standard rooftop unit, essentially as a makeup air unit. And for those of you that deal with this on a somewhat regular basis, you'll know what I'm talking about. A standard rooftop unit cannot be used as a makeup air unit because you cannot open the outside air damper more than 50%.
Well, you can, but
could-
you can't do it on a regular basis. The
Right.
heat exchanger, if it's 10 degrees outside and you open the outside air wide open, you're going to rust out the heat exchanger. You're just going to sweat. I worked for the train company for many years, and their rule of thumb was never more than 50%. If you have a stainless steel heat exchanger, you might get away with a little bit more, but it's also hard on the cooling side as well. It's not, if it's 98 degrees outside and 100% humidity, it's not designed to put that kind of load on it.
Right.
And on the big one is, and in the earlier years, we would help contractors do this. We've officially taken a stance. We will not help you use a rooftop unit for ventilation anymore. We saw it. We helped the contractor get it hooked up, and within 2 weeks, somebody did not understand what was going on, thought the unit had failed, disconnected all the life safety, and there was no life safety. They pulled out the relays that drove the economizers wide open because they didn't know, and there was no safety left. So our official stance is we'll make a recommendation, the engineer change it, and we're prepared to walk away from a job if they try to use a standard rooftop as life safety.
It's life safety. You would never do that with a gas detection or a smoke evac situation.
Well, actually, if you use a real high-end rooftop, some
They
real
have it in it.
high-end rooftops are designed for smoke evac. If the system's designed for smoke evac, then we're okay with it. If it's not, if we're cutting into the economizer section of a rooftop, our opinion is that's not how we do life safety.
And the reality there is it's usually just to save a couple bucks.
Yeah.
And there's no reason to save a couple bucks when it comes to life safety. Do it right so that everybody's safe and happy and you don't have the liability.
Yep.
Right? Okay. We got a question online here real quick. CO and CO2 monitors detect flammability? The CO2 monitors detect flammability and toxicity of refrigerant gas. Oh, do they? No, they do not. And so we'll talk a little bit about that shortly, but to answer your question specifically, CO and CO2 don't detect any refrigerant
Right.
at all, and they certainly don't detect any flammability at all. They specifically only look for CO, CO2, it's the specific gas.
This particular sensor will do, with the right module in it, will do about 20 different gases.
Right.
Refrigerant is not one of them.
Correct.
And so if you have multiple gases, whether it's refrigerant, CO, NO2, you have to have a separate sensor for every gas.
Correct. Okay. All right, so toxic and explosive gas detection system selection. You got two different types, standalone and networked, okay? Standalone meaning we just have a panel and we have sensors and they're doing their thing. Networked meaning that we are communicating with it in some way, shape, or form, okay? So standalone is typically smaller applications, 5, maybe less, depends on what we're doing. A lot of times standalone meaning just the sensor or 2. So let's use a firehouse as an example. Small firehouse, it's got 2 engines in it, it's got 2 bays. You don't need very many sensors. You just really need a CO and an NO2 sensor, and that's it. We can use just a sensor or 2 sensors, wire those directly to the fan, directly to the louvers, whatever it might be, and we're done. It's not a network situation. It's completely standalone. We might also have a panel if there's a larger firehouse, and it's just a very small panel. Actually, this panel right up here behind us. And that is still considered a standalone situation because we're not communicating with it at all. We're not doing anything other than making sure we bring on the fan or open the damp or whatever it might be. When we get to networked, when we talk about larger applications, we're actually communicating with our panel. We're actually putting a communication wire between the sensors and the panel itself. We are making sure that we are getting alarms at both the sensor and the panel level. So there's a lot more, not a lot more to it, but just a little bit more to it. We're actually programming the panel and the sensors to do specific things. So there's a lot more to it in terms of that. And then networked can also mean we're actually communicating or providing alarms to a building automation system. So there's two different types of systems like that. Not much more to tell you, but that same, no matter whether it's networked or not, same sensor is used.
Yep.
Right? Okay. Moving on. Gas detection control panels. Multiple control panels should be available from the manufacturer that you're using, and they should be able to scale the job that you have in mind. So, as an example, I mentioned we have a 4 sensor panel that we use. A 4 sensor panel meaning I can put 2 CO, 2 NO2 sensors on it, and it's a small application. This is a much less expensive option over having to use a 124 sensor panel and then only using 4 sensors. Obviously, this is a much lesser expensive situation. Also a 32 sensor panel, which is the panel we have right here. 32 sensors meaning almost every job we do. Almost every job we do is less than 32 sensors. Rarely do we have one that's more. And when we do, we use 2 of these instead of using the really big panel because the cost savings is there, right? Now, if we still have to have one, the engineer says we have to have one panel in one location, yeah, we'll use the big one. But if he doesn't, let's use a parking garage as an example. We got a 4-story parking garage that has 18 sensors on each floor. Put one of these on every floor, it's still cheaper than using the big one, right? So lots of different things we can do with that, but it's scalable.
And it's also a lot easier to troubleshoot, to
Yep.
set up. It's nice to be working on one floor and go to the panel and see what's going on versus, putting the panel on the top floor and working on a sensor on the first floor and running back and forth between floors. So we really like breaking parking garages down by floor. But up to 128 sensors would be a really big parking garage.
Yep. And so the large panel that we offer is a very, very large panel. It's 128 sensors, stainless steel construction, NEMA 4 enclosure. Got a touch screen on it. You can play Angry Birds on the touch screen. It's very fun. I'm joking. It's got an Android tablet in it. But the nice thing about that one is just the sheer size of it and the fact that it can communicate via BACnet if we need it to. However, Joe, I want you to talk about that, about communicating with a building automation system with gas detection.
So there's a couple ways to go about it. These sensors use their own little proprietary communication protocol, and they talk directly with one of these 2 panels or even the larger one. But this same sensor is available with BACnet. So if a customer wants to tie all the sensors directly into his BACnet control system and then he controls all the fan, our personal opinion is that's a bad choice because now he's taking all the responsibility on him. We don't do that here. We have the capability to, but we always run everything through a control panel for liability reasons. All the fail safes are all built in. So you can do directly to a building automation system. You can do proprietary protocol between a sensor and a panel, and then you can take the panel information and send it up to the building automation system. Most of the time, we don't suggest sending all that data up there. We put out 2 alarm contacts, one that says you have a failure on your system, and 2 that says you've been above 50 parts per million for 10 minutes or whatever, notifying there's not a failure, but you do have a high level. So a high level and a failure contact into a building automation system is a much more economical way to do it. If you do decide you need to get all those points in there, we can help with that. We're very familiar with BACnet, and we're not going to do Johnson Medicine's programming for you, but if it's a standard tritium-based control system, we can even help you with that as well. Sure. So our recommendation, contact closure, clean, simple, reliable, no programming errors. So simple.
There you go. We always should avoid mounting control panels in common areas just because people are curious and they start pushing buttons. We don't want that. So yes, there's this code protected and it's locked and all those things, but if you can avoid it, don't just put it out in the common space. And then should have the capability of programming alarms and relays and whatnot. The manufacturer should always provide pre-programming of the system for the contractor. We here at Specify Controls will pre-program the system for you as the contractor. And so what that actually means is that Joe or one of his team will lay out your system. They will wire it all up. They will program in exactly what the alarm levels should be. They will address the sensors, and it will show up to your shop ready to go.
Yep.
For all practical purposes, plug and play.
Yeah, we'd normally put the address of the sensor, so when the main panel says sensor 3 is in alarm, you know right where to go to look. The panel's pre-programmed for you. You can program it yourself.
It comes with software.
Yeah, it comes with a little software CD and a USB serial cable. Real easy to program on your own as long as you carry a laptop. I personally don't even want to do it through the front panel. The software documents everything that you did, which is really, really important to us. Now when we send out a system, it not only is a pre-programmed, but you get a PDF file of exactly how the system was programmed. And so if there's any question in the future, you have it fully documented about you did have it programmed correctly. And if it's changed 2 years from now and there's an issue, you have proof that it was programmed correctly. You can't get that documentation out of it if you program it from the front screen. It's capable to do it, but doing it through software just gives you a backup file, gives you a hard copy of the programming, and really simple to use.
Right. And the other thing I was going to add to that is, from a programming standpoint, we're going to provide custom wiring diagrams. We're going to provide engineering, and we're going to provide a pre-programmed system so that if you've never done this before or you're not very familiar with it, we make it very easy for you as a contractor. Okay? All right, so we've got a couple quick questions online. Where do you usually find NO2 gases the most? Anywhere there is a diesel engine. That's
Fire stations are big.
Fire stations.
Big warehouses, like if they pull UPS trucks into a warehouse, that's a big one. We did the warehouse for UPS over in Plainfield, and they've got hundreds of sensors throughout the complex.
Right. I was going to say, essentially anywhere there's semi-trucks, anywhere there's trucks with stacks at all, anywhere that you're going to have.
Anywhere there's Volkswagens.
Anywhere there's Volkswagens, yeah.
Or Dodge pickup trucks.
But I was going to say, anywhere up north, as an example, where they're storing snow plows and salt and things like that, there's going to be diesel engines. So the real answer to that is anywhere there's diesel engines.
And I would say 75% of the parking garage projects that we see are CO and NO2.
Right.
The other, 25% are CO only.
It's code in most municipalities at this point to have CO and NO2 because of the deadliness of CO or of NO2. So I hope that answers your question, Ricardo. Next question is there is the software Apple compatible?
It is not.
It is not Apple compatible.
Nope.
There you go. Sorry. Something we'll certainly request moving forward, because I didn't realize that either, but it is not Apple compatible. I don't know how to describe it other than to say, if you're old enough to remember what Minesweeper was, that's what it looks like. But it's fantastic software, and it's super easy to use, but it's not the most up-to-date, fancy-looking software you'll ever see.
Yeah, there's no reason for them to do a lot of updates.
Right.
And I say it's not Apple compatible, but I did have one customer call and said that's the only thing he has. But he was really good with his machine. He put a virtual Windows machine on top of his Apple machine, and then he ran the software without any trouble. So you have to have a Windows-based operating system.
Yep.
Gases in like large pole barns for farm equipment?
Absolutely.
If they're
Without
diesel,
question.
absolutely.
Absolutely, yeah. You'd run into it without question. The question here locally was, would you run into this on a farm? Would you run into this at pole barns and things like that? Absolutely. Diesel generators. I could think of multiple situations where you would have NO2 in a farm application, for sure. Absolutely.
Just on the farm line of thought, we actually do a lot of chicken coops across the Midwest, and ammonia in chicken coops is a really big thing, and CO2 is a really big thing. We've done houses.
Chicken shit is a big thing. Just saying.
I don't have a chicken shit sensor, but we do houses with 250,000 birds in it, and so we usually end up with ammonia sensors and CO2 sensors just to keep the birds from suffocating.
Right. Okay. And then, we got a lot of questions here. So it's Apple, we got that one. Several environments have been discussed, but not large restaurants that have kitchen equipment using LP and natural gas. Are there any concerns in that environment? Absolutely. There can be concerns in that environment. I've seen that two different ways. We actually have LP sensors that will sense a leak. So we've seen those in large kitchens. And then CO2, we see quite a bit because the byproduct of natural gas burning is, CO. CO, carbon monoxide, is the byproduct of natural gas when it's burned. So we've seen both in that situation. I won't say that I've seen code that requires it, but I will say from a safety standpoint, it's definitively a concern.
Yeah.
And so yes, we have seen it. Typically, the only places I've seen it is pretty large facilities,
like almost an industrial kitchen. I
Yeah.
haven't seen it. I have not personally
Yep.
seen it in a commercial restaurant, but
Right.
Natural gas detection.
Yeah, I've seen it in like large hotels where they have like a convention center kind of a thing.
Right.
Where it's just a gigantic kitchen, but not in a Applebee's, as an example. So, all right. Is there any plan to make the software compatible? Mark asks. I'm going to find that out, Mark. I don't know.
We have not heard anything about
We
it.
have not heard anything about it. Makes sense that we should do that, but we'll get that figured out. How you ever did for NH3 on wall and freezers where the temperature is very low, sensor has to be for low temp.
I'd have to check the temperature range of the sensor. There's no problem in a typical parking garage where it drops down below freezing. But if you're talking about something that's 20 below, I think that is beyond the range of the sensor. But I'd have to double check that.
Keep going, Joe. Is there anything else there I was going to look it up real quick.
I'm not sure what gas we'd be checking for inside of a freezer.
I will say, refrigerant-wise, we do have a refrigerant monitor. We weren't going to talk a whole lot about refrigerant monitors today, but we do have a refrigerant monitor that can tie right into the panels we've talked about so far. That refrigerant monitor's operating temperature is from -40 up to, I believe it's 125 degrees Fahrenheit. So we have actually placed that refrigerant monitor, which looks just like this.
Yep.
We've actually placed that inside freezers and walk-in coolers, worried about refrigerant leaks. But NH3, I'm not sure, so I'm looking that up if I can find it.
So while he's looking that up, one of the things that we really like about the system, and the reason we don't tie sensors directly into building automation, is this panel knows when one of these sensors fails. So when a sensor fails, we always set the system up to turn on the exhaust fans. So if we have a dead sensor, number 4 or whatever, it comes up and tells you that the sensor has failed, and it'll automatically start the exhaust fan. So if there is a problem there with the dead sensor or a failed sensor, the system goes ahead and operates. We can also set the panel up so that loss of power to the panel will run on the normally closed contacts, so that we can force the fans on in case this panel fails or power is removed from it. So lots of built-in safety things that you may not think about if you're writing code inside of a BACnet controller. So and it does relieve you of a lot of liability if you're using a predefined system that it was designed to do the exact application.
Let's found the answer. So the sensor we're looking at right here, which is capable of about 40 something different gases, is temperature range is -40 to 70 degrees. Excuse me, I'm sorry. That's Celsius. -40 to 158 degrees Fahrenheit, depending on the sensor itself. So, to give you the answer on NH3, which essentially is ammonia, it is -40 to 158. So, we can do that.
Yep.
You could mount that right in the freezer if you chose to. There you go. Yes, sir.
On the sensors,
Yep.
if it fails, does that turn that light on?
Not
Good question.
Depends.
The answer is,
Or the
if we set it,
panel, either one.
so the control panel tells you that there's a failure with a
You have to have somebody, if it's put in a closet, you have to have somebody open that door regularly.
Right.
You're right. So it turns on a little failure light here. The screen tells you which sensor failed, and you can set up inside there's on this particular one.
Jump in real quick. The question was, if we have a sensor failure, how do we know? right?
Right.
Sum it up. So how do we know if there's a sensor failure? Go ahead.
So it turns on a failure light. It tells you which sensor fails, and then there's an output specifically designed for your strobe and horn. If you tell that to turn that on a failure, it turns that on a failure. You don't have to do that, but it's just a checkbox. We always
If the strobe thing is out where somebody can see it, somebody's going to check it.
Right.
absolutely.
Check that
No,
box.
you're absolutely right.
Yeah, absolutely.
I always check.
Basis or daily.
I always check in the program. I always hit the checkbox, turn on strobe and horn on failure. I turn on the fans on a failure, which kind of notifies people the fan's running continuously. There's a problem. And I turn on the fans and the strobe and horn. Also, the panel has a button that they call hush. So this panel has a horn in it that's nearly deafening.
Yeah.
So if you're trying to figure out what's going on with it, and you can't even think because it's so loud, you can come up and hit the hush button. It'll turn that horn off, and you can get your wits about you,
Right.
figure out what the problem is and what you're going to do to solve it, and then put everything back to normal. So yes, it can light it. Yes, it will scream at you, and it'll tell you which sensor failed, and it'll tell you because it can scream at you just because the gas levels are high, but it'll tell you there's a failure, tell you which sensor is failure, scream at you, and turn on a light if you'd like. So any of those options, and we sell it, so I like to brag about it, but I really do like it. It's super easy to set up, and everything that you might ask it to do, it can do it by just checking a box.
Right. The other thing I was going to add is we have another product that it's just a simple wall plate that has a light, a horn, and a silence button. And you could just put that, wire it to the panel, and then put that in a manager's office or facilities guy's office, and then he would know there's something wrong with the gas detection system, even though I'm not in the warehouse or I'm not out there. So that's another option. Instead of having just the strobe be your warning, you could also have it in someone's office. Just real simple. Yes, sir.
Are these the same kind of sensors that are put in power plants?
In most cases, yes. Yeah. The only difference it might be if the power plant requires explosion-proof sensors. The question was, are these type of sensors found in power plants? Yes and no, depending upon the requirements of the job.
I know that EPA regulations
Yep.
require certain things.
Specific things, sure.
Yeah, and so these sensors, well, they don't look the same. They're made in an explosion-proof version as well. So if you're going to be in a place that
Requires
has that kind of potential, then we need it. And we also do a lot of wastewater treatment facilities, so there's a lot of methane gas. So we always use the explosion-proof version in the wastewater facilities.
Sure. Do you have a question?
Yeah. If now that you guys sell these smart systems,
Sure, absolutely.
is there I guess like a smart version of this that can send out text or email notifications about sensor
There,
failures or?
So this actually, well, we don't use it very often.
I'm going to jump. The
Okay.
question was, can we get text messages or any kind of online notification of any kind from this system itself? Go ahead, Joe.
So it can send out an email notifying you that there's a problem via a phone line, not a straight internet connection. It has to be a standard phone line. We don't see that very often. Somebody ought to be in the building checking it on a regular basis anyway. So I don't remember the last time we used the functionality, but it has a standard communication jack, and it's all set up to go if you'd like for it to send out
I
notifications.
was thinking more along the lines of like you use large-scale apartment buildings
Yep.
where you have 300, 400 units.
Right.
It's like you're in the mechanic's office or maintenance office, and sensor 400 down the other
Right.
side of the house.
We don't see this product in a residential, in the actual living space very often. I've never seen this particular one in a living space. You could.
I'll jump in and say where I have seen this is in a townhome, a row house kind of a setup where there's integral garages, and
Yeah, I've
code
seen it there.
dictated that they had to have CO and NO2 sensors in those garages, but it didn't have anything to do. Didn't say anything about them having to be networked or anything. So in that application, what we simply did was wired a CO and NO2 sensor to I'll call it what it is, a fart fan, on the garage, and that was all we had to do. But I see your point about how you could maybe tie that in and they would know if it failed. But we set up the sensors to where they would alarm if there was a failure, and the horn would go off. And so the owner at that point would know, or the lease person would know, like, hey, there's something wrong, I need to call.
And as a standalone, even if you didn't have a panel, this has got a built-in buzzer to notify you if the levels are too high. And completely programmable as well.
Yes, Rand?
It's completely hardwired, everything?
It is
Yes,
all
all
hardwired.
What, you use a special wire, like a wire, fireproof insulation or anything like that?
Question is what wiring, what type of wire to use? Go ahead, Joe.
So the communication wire, we use the same wire that we use with BACnet, which is 22 gauge twisted shielded 2-conductor cable. And for power, if there are very many of them, we use a 16 gauge twisted shielded cable. It would talk over thermostat wire, but don't. It's life safety.
But not fireproof.
No, not fireproof.
No, it doesn't have to be fireproof.
And then so in most cases, if
in
it's
conduit.
if it's in a parking garage, it's almost always in conduit. And the exception is we're doing one right now, and we actually see this a lot. One of the reasons for having the system is that the parking garage is below the apartments. Actually, all of the plumbing from that first floor apartment is in the ceiling of the parking garage. So we can't run the fans or we'll freeze their plumbing. So it has a drop ceiling. So once we ran conduit up to the drop ceiling, then went to free air plenum rated cable above the drop ceiling, and then when we drop back down, we go back to conduit again. But almost always in a parking garage, anything exposed is in conduit.
Right. Most dealerships.
So not fireproof. If the building's on fire, I guess they
already know to get out at that point.
Yeah.
No, but to answer the simple question is what we always suggest is 16 gauge twisted shielded two conductor for power and 22 for communication. Yep. Okay.
Another question.
Yep.
We were talking about the molecular weight,
Uh-huh.
like NO2.
Uh-huh.
So where do you locate that sensor?
NO2?
Would it be just for NO2
Right.
and not for CO2?
Sure.
Every sensor, it's a different sensor for every gas.
Oh, I'm sorry.
Right.
I thought you said
Right.
that.
Different sensor for every gas.
It can do one or the other. It can't do both at the same time.
Right. Right. The question was very simply about height and those things. We'll get to that, Rand, I promise. We're going to get to it. Okay, couple quick questions. How often do you calibrate the sensors? You don't. They're self-calibrating.
Well, they come pre-calibrated.
Right, pre-calibrated, right.
Here at Jackson Systems, we send out what we call bump gas, so you can confirm that they all work. We don't. You can, if you wanted to, you can buy calibrated gas, and you can calibrate them once a year if you want. Most of the time, we're not seeing them getting calibrated. We say hit them with bump gas once a year. After 5 years, calibrate or not, they go.
Right.
And so calibration is definitely doable. They have the calibration kit to do it, and the calibrated gas, and you hook up a little hose, and it puts out exactly 25 parts per million, and you make sure everything's squared away, and you can adjust the calibration through the front of the sensor. We don't see a whole lot of that going on. It's either usually a go or no go with them.
Right. Can the controller talk BACnet? Technically, the controllers that we offer cannot talk BACnet by themselves. There's an add-on feature.
Well,
This one.
the small one cannot.
Right.
The medium one cannot. The large one, the 126 device one, if you add the BACnet card to it, it can.
It can. Sensors themselves, there is an option to get the sensor with a BACnet card in it.
Mm-hmm.
You can do that. We talked about it a little earlier, not necessarily our suggestion to do it that way, but you can do that.
You take on a lot of liability when you do that.
Okay. So let's see here. Okay. Is it possible to activate or deactivate the sensors or control panel with a cell phone? Kind of talked about that earlier. Currently, there is not really that option to do that. And I guess I would say to that is it should always be active. And we shouldn't
there should
deactivate
never be a
it.
deactivation. Yeah.
Yeah, because even if the building is not occupied, we still need to know if there is a gas leak, a problem. Somebody could just walk in I'll use the example, the building's for sale, it's vacant. A couple people walk in to buy it and it's completely filled with CO. We got a problem. So
No, there's no cell phone interface to any of the systems.
Right. Okay. Let's see here. We'll move on real quick here. Each gas detection job is different or custom. That's very important to point out. They are never just the same. It's always different because this is life safety. And then just about equipment selection, the sensors themselves are capable of 4 to 20 milliamps output. They're capable of 1 to 5 VDC, and they're capable of 2 to 10 VDC. This allows for modulation of dampers, EC motors, whatever it might be, through the sensor. There's also digital RS-45, which allows them to communicate over their...
These two guys to talk to each other.
They can talk to each other through their own proprietary protocol. Then each panel has 3 relays in it. Those relays, as an example, if I've got 3 louvers and 3 fans, I'm going to bring on all of those at the same time. So I just need 1 relay out of that panel. I got 2 more relays I can do other things with. If I'm going to stage that, or I'm going to zone that where, okay, if the sensors in this area go off and I want the fan and the louvers just in that area to go off at that time, or open or start, then we might use all 3, right? But we're capable, we can add actually an M relay panel. We can add multiple relay panels to this panel. And the relay panels, there's nothing exciting to show you. There's just a bunch of relays in it. The relays, we can do up to 96 relays off 1 panel. So we can do all kinds of crazy stuff. We can start turning on Christmas lights and whatever you want.
Based on CO level?
Yeah, why not? Sure. But we can do all kinds of things. So just know that there is no real limitation to the panels that we can offer in terms of what they can do and what they can bring on zone in terms of fans and louvers and things.
You're 100% right, but I would say 90% of the jobs, 3 relays is enough to get the job done. There's typically a low-speed fan running, and if you have up to more than 3 zones, you typically end up with more than the 32 sensors it'll do. So most of the time, this will do all of them you need. But we've seen a lot of service bays where they want to turn on an exhaust fan and open the high-speed overhead doors to let fresh air in. So maybe you want those on 2 separate relays.
You got one on your desk right now to look at?
I do.
Yeah. So last thing is BACnet. We talked about that earlier, but the panel and individual sensors are available with communication to a building automation system through BACnet, but it's only the one large, as we call it, a Q controller that is capable of doing that, and then the sensors themselves. All right. So what is the correct sensor in terms of the gas? Which type of sensor is needed? Do we need a standard sensor, just hanging on the wall? Do we need a duct-mounted version of this, which is this sensor with a added duct head and a tube and a probe? Do we need explosion-proof? I want to clarify for those of you that might not know the difference. Explosion-proof does not mean it won't explode. It doesn't mean that at all. What it means is that it won't create shrapnel, meaning that if there's gas inside the sensor and it explodes, it will not.
It's not coming apart.
It's not coming apart and going to destroy the room it's in. Okay, so just clarify what that means. Which gas? Dozens of options. There are literally dozens of different gases and ranges of gas, right? So it's very important to know what we're dealing with in terms of what could be in the space if we're looking to select the right gas. The most common gases that we see are CO, NO2, hydrogen, CO2, and then gasoline and diesel fumes themselves. So combustible fumes themselves. So in a car dealership, as an example, they might have a big tank, gasoline tank there to fill cars up with, and they want to see if there's a leak or know if the fumes are actually leaking out of it. So things like that is what we see most commonly, but there's all kinds of different gases out there that we can alarm on, right? What's the range and distance? Very important to keep this in mind, range and distance of the sensors. Almost all gas detection sensors have a range of 48-foot radius, okay?
And that really has nothing to do with the sensor.
Right.
It really has to do with how fumes migrate and things like that.
But almost all of them are 48 foot. There are some that are less, and there are some situations where an engineer will absolutely ignore what the actual radius is because he wants it to alarm faster. He wants to put a flammable a flammable gas sensor closer. So he'll put double the amount of fume sensors because he wants to make sure that fumes never get too high, right? So there's lots of different pieces that go to this, but as a general statement, almost every gas detection sensor you're going to come across with regularity is going to have a 48-foot radius.
So we get a lot of projects that don't show us where the sensors go.
Right.
And you can't be in the gas detection business without a compass. So we measure off 48 foot and start drawing circles. And we'd like to have 100% coverage, but generally if we could get 90%
Right.
of the area covered in those circles, that's probably good. The other challenge is sometimes they're free-span buildings and there's literally no place to put the sensors to get that kind of coverage. And then we have to
Get creative.
yeah,
We have to get creative.
Yep.
But the other thing I'll point out there as far as radiuses go is this is life safety. If you're looking at a set of plans, you're looking at what the engineer laid out, and he just puts a couple of sensors on there and then writes per manufacturer recommendation, you really need to make sure that you don't just provide a price off of 2 of them.
And usually when that happens, we'll price it both ways for you.
Yep.
And we'll say, hey, look, so to make sure you're competitive, here's what they ask you to provide or what they showed on the plans, and here's what you really ought to have to get the kind of coverage you need.
Right. And then the other question to ask is it explosive gas or toxic gas? Will the gas explode, or will it displace oxygen, or will it simply kill somebody? Okay? So those are all important things, and all have varying prices. So, a CO and NO2 sensor is, those sensors are the same price, and they are that price. You get into explosive gases, it becomes a different type of sensor, and it has a higher expense. So when you get into explosive gas, you start talking about catalytic beads and some other
And it's an
infrared.
explosive proof enclosures,
Right.
which takes the price and drives it to the ceiling.
Yep. So just know that with each job, it's custom, and there's different pieces that go into that. Okay?
And we're here to help with that.
Right. That's what we're here for. Okay. Quantity of sensors and planned locations determined by coverage area of each sensor. As we said, 48 foot or 7,238 square foot radius. Use open air pillars if possible in any parking garage or any building. So as an example, we have a warehouse down here that's got pillars running down 2 sides of it. We would put the sensors on those pillars so that we cover a lot greater area, so we would need less sensors. Whereas if you got a free span building with no pillars, you got to put them on all the outside walls. Then you got to figure out how to cover the middle of that building. So on the screen here, you can see we've got about 90% coverage. That's on a very oddly shaped parking
Except for
garage.
the one space that doesn't really have any cars.
Yeah,
in
there's
it.
nothing. That's actually just a room area
That happens to be the Penrose parking garage down on Mass Ave
in Indianapolis.
in Indianapolis. Yeah.
So in this situation, not a lot of pillars. So
Yeah.
there wasn't a lot of options of where to hang it. But we got darn close to 90% coverage. And that's functioning and working right now today. All right. So real quick, we always like to ask a couple questions. Why should a standard rooftop not be used for fresh air or makeup air in a gas detection system? So you think about that. We talked about that earlier. Why should you not use it? Okay? And we're going to jump to some questions that were brought up. So Mark is asking, is there a specific sensor for propane or is it included in another sensor? Mark, there is a specific sensor for propane fumes. There is one specifically for propane fumes. In most cases, when we see like a warehouse that has fork trucks in it that are propane, we CO everywhere in the warehouse. And there will be propane sensor just where they store propane tanks or where they change out the propane tanks. They won't put propane everywhere. So that's just a note to point out. But propane sensor is its own sensor. Yes, sir. Do you use and how do you on a power outage? So Constantino, how are you? Glad you joined us. Constantino is asking, do you use and how do on a power? So I think he's asking if we had a power outage, what happens?
So I guess if there's a power outage, your exhaust fans aren't going to run anyway.
Right.
So I guess that's not something that's been brought to us. You could easily run this off of a small UPS battery backup. I'm guessing a standard one like you'd use for your home PC or something. You're going to get maybe 30 minutes out of it at the most. It's not going to run a long time. The sensors are also powered out of this panel. So if you had a very big system, you're not going to get it to run very long. I guess if that's a concern, obviously the fans need to be on a generator system. if there's a chance you're going to be running vehicles in a garage without any power, I guess the garage has to be on a backup generator, and that backup generator ought to power the exhaust fans and the system.
Right. I'll just point out, I've dealt with this a couple of times where they just wanted to make sure an alarm went off if there was power outage and there was CO or NO2 issue or something like that in the building, and they used a backup PC battery pack.
It'll run for a little while.
And the engineer just said, I just want to run it for 15 minutes. I just want to make sure it's fine. And they did that, and it worked just fine. They used just a standard PC battery backup, and it worked just fine. This is all low voltage, so not a big deal there, but it's not going to run for a long time.
Yeah, you plug your transformer into your UPS with cut your extension cord off.
Right.
So it will work. It's just not going to give you 8 hours of coverage or anything like that. It's going to be some fractional part of an hour.
So back to the question, why should we not use a standard rooftop? Clarify, standard rooftop. Buy it from the carrier distributor, and it's just throwing it in there. Why, Joe?
It's not safe, for one thing. The equipment wasn't designed to run 100% outside air, and so you're going to damage heat exchangers. You're overriding the outside air damper, which is most economizers are a little bit confusing anyway. So you get a tech who doesn't realize that is life safety equipment that's causing his economizer to do strange thing, and they disconnect it, and now we have a real problem.
The big issue is the next service tech that comes in that doesn't know why a set of wires is running up to the rooftop unit from nowhere.
He got a complaint that there's no heat in the middle of winter. He goes up there, sees the outside air damper wide open because there's carbon monoxide, and he disables it. Just a bad choice.
Bad choice. All right. Okay, so sensor height, one of the most important questions we get, and Rand, who is here in the office, left to go to the bathroom. We'll circle back around for Rand when he comes back. The real answer to sensor height is it completely depends on what type of gas it is. There is no definitive answer because it not only depends on what type of gas, but it also depends on what is generating the gas.
What type of vehicle.
What type of vehicle, as an example. So we've talked a lot about different applications. Let's talk about a UPS facility where a lot of semi-trucks drive through. Well, they got stacks on them. The stacks, the exhaust comes out of the stacks, and that exhaust is superheated and it rises. Well, the stacks are already 12 feet high, 10 feet high. Well, now they're going to go up higher. So we want to put the sensor up high so that it catches the NO2 before it falls into the breathing zone and people get sick. But if we're in a Mercedes-Benz dealership or a Volkswagen dealership, then
or Dodge truck dealership.
They're not going to have stacks. So the NO2 is now going to exhaust about 2 feet, 3 feet from the floor. Now it will rise, but it will also fall. So we want
as it cools.
As it cools. So what we want to do then is put it down low to catch it before it hits the breathing zone where people would actually breathe it. So it all depends on application, what kind of vehicles we're dealing with, and then specifically the gas. As an example, hydrogen, we're going to put up high. Hydrogen is much lighter than air. It's going to rise. When we deal with CO, we're always going to put right at about 54 inches, right in that breathing zone. There are some talks of changing that a little bit in terms of ASHRAE and some other organizations saying that because of APA standards, ADA, American with Disabilities, 54 inches is too high. So there's talk of moving it down. But regardless, it should be in the breathing zone, basically. And so that's where CO should always go, as you can see on the screen here. We show you where CO should go. We show two different options in terms of NO2 and CO on the screen. But it all depends on local code. It all depends on what type of gas, and it all depends on what type of vehicles. We got a question in here.
Yeah, kind of off topic.
Sure.
Oddly specific. I'm assuming you guys have an argon sensor, correct?
Not.
We have
indoor air quality sensors that pick up.
No, I think we have acetylene, and I think we have.
Okay.
I think we have.
Welding.
Yeah, I couldn't think of.
Okay.
I kept wanting to think of another name for. Yeah, we have acetylene.
So my question is, so that gas is obviously a lot
I would probably say we should put it a little bit higher than the height of the tanks, is what I would say. But I would also say that we would want to put it above the breathing zone, and we always say the breathing zone is about 54 inches. So if the tanks are real low, we still would probably want to put it a little higher than 54 inches, is what I would say to that. But also we have some specialists that deal with that stuff. I'm the fast talking sales guy, so I know a little bit about this, but I'm not, the question was about welding gases, acetylene or argon or anything like that, and where the sensor height should be. And the simple answer is probably right above the breathing zone is the right answer. However, in that situation, if the engineer or if it was a design build kind of situation where you were just helping them out, we'd we'd definitely get an answer, definitive answer. Right. Yeah. It'll shoot that cap right off. Yeah. Bottom of the tank right off. I don't have all of the explosive gases on this sheet. It's just our general one, but I know we have acetylene and I know we have another one, and I can't think of what it is that we can do for sure. Okay. All right. So moving on from sensor height, audio and visual alarms. We're
gonna circle back around.
Yeah, we talked all about it. Audible and visual alarms. I'm gonna make this really simple and try to move forward here a little bit. As far as audio and visual alarms, virtually every engineer out there is going to say sensor or system with audio and visual alarm. Every manufacturer that makes gas detection panels and sensors has an audible and visual alarm in the sensor and on the panel. The difference is that if you look at this sensor, I don't know, Tyler, can you zoom in on that? Or Alex? If you zoom in on that sensor, you'll see where the lights are. They're right here. That is meeting the spec of a visual alarm. You can't see that from across the room, but that is meeting the spec. The horn in here is about 70 decibels. If you're in a warehouse, you can't hear that. It's not loud enough.
You can hear this one though.
But you can hear that one. That one's about 120. So what I'm getting at is everybody out there that makes this is going to meet that spec. But what they're not going to provide in their product is a strobe and horn. An actual light that they can see, an actual horn that they can definitively hear that is specifically for this purpose. Also, I'll point out that with gas detection, OSHA's requirements are that it is a constant buzzer. So, smoke alarms are that bing, bing, bing. This is supposed to be a constant buzzer sound. This is a constant buzzer. This is a constant buzzer, but it's not nearly what the engineer probably thinks it is. So I just point that out in terms of if we're going to meet the spec, okay, we can meet the spec. If we are going to do this the right way, we should probably include a horn and strobe.
And
Simple
most
as
of
that.
the time, if you ask us to help put together pricing for you, and it doesn't specifically say a strobe and a horn at the bottom of the page, we recommend that you put a strobe and horn on. Here's the
the
price.
ad.
We understand that a lot of times you have to be low bid. So maybe you go in and say, hey, here it is per the specifications, but we know that you need this as well.
And then the last thing on this page here, you'll see the warning signs again. Strongly suggest it. Just can't reiterate it enough. Throw some warning signs up there. If people, you all know this, smoke alarm goes off, nobody does anything. They're just like, I don't see any smoke, and so they just ignore it. Well, you will never see this gas. You will never know it's there. You will just start coughing and fall down, and you're going to have the EMS come and help you, or worse. So, this is something you need to make sure that they're aware of and they know why this is going on. Okay? All right. Warning signs we talked enough about. Special environments and accessories. Depending upon the structure, special circumstances may be necessary. As an example, splash guards. As an example, wire cage protectors we suggest in a lot of cases. especially in, let's say, a
College.
college parking garage. We've had that, but also when a lot of times when we're doing a car dealership, we are going to want to put the NO2 sensor down low because it's a Volkswagen dealer or a Mercedes dealer or something like that. Put a cage over that one that's down here because they're going to shove their toolboxes into it. They're going to throw stuff, and it's worth putting it on there to protect it. Splash guards might be a wash bay for semis and things like that. So there's lots of different applications where that is necessary as well. And then explosion-proof sensors may be necessary in specific applications, as we've talked about throughout this. Not common in parking garages at all. Car dealerships or warehouses, you just don't see that. It's much more of an industrial thing where they need explosion-proof, or they're specifically working with combustible gases that they're concerned about that. So rarely do you see explosion-proof unless it's just a specific application. And then note here, we see this more and more now. Hydrogen is created when you
Charge a
car
Or a fork truck.
Electric cars, forklifts, etc. Hydrogen sensors may need to be explosion-proof sensors. They might need to be that. It depends on the local code. With the addition of electrical charging stations in parking garages, they need hydrogen sensors in that parking garage. Just quoted one last week that was in Florida, where they had about 50 parking spots per floor. There were 4 floors, and there were 10 charging stations on every floor. If you had 10 cars charging, there's a lot of hydrogen getting generated. And it's Florida. Crazy things happen in Florida. So strongly suggest that if the hydrogen sensors are not there, that we'll help you with that in terms of quoting it, but we will always suggest if we see any charging stations that a hydrogen sensor is included. Engineers, most of the time, just don't realize it or pay attention to that, but it's something to very, very much be concerned about. All right. Closeout procedures on gas detection systems. Joe, I'll let you handle this because you do this all the time.
Well, I can't read the screen from here, but
startup is first.
Yeah. So every system needs to be started up. We pre-program every system for you, but it still needs to be confirmed that it all works. We send out test gas. I always cause one of the sensors to fail to make sure that starts the system up. So you definitely have to do startup and check out. Inspect field installation. We don't always do startup for the customers because we do pre-program, but if we do go out, we make sure they have the right kind of wire pulled. We make sure that they got the right voltage to everything. So definitely check to make sure everything was installed correctly, including sensor height, which seems to vary from job to job. We test the system. Like I said, we usually just do what we call a bump test, which means we'll walk around to each sensor, hit it with a shot of gas. The panel usually includes time delays in it, so we don't instantaneously turn on a fan. So I usually take the time delays out while we do the startup test and then put them back after we're done. We always talked about the test gas. We send that out with every panel. Verify connections with the sensors via fan, damper, louvers working properly. Yeah. So along with the gas techs, we got to make sure that all the equipment works. If I'm there, I usually check to make sure the fans are rotating the right way. I make sure the louvers are really opening. All of those things that are mechanical in nature, I always help check those out as well. We always do demo and training for both the contractor. This is, again, assuming they've asked us to help with startup. We do training for both the contractor and the owner, so the owner knows how to deal with the system. And we got a call the other day, a screenshot of our system, and it showed it had some of the fans turned on. I said, well, it was actually that Penrose building. And they said, well, what's wrong here? Nothing's wrong. There's carbon monoxide in the building. The system's running. It's great. Glad to see it's working. We had not done owner training there yet because they may want to make some changes. But anyway, so owner training and contractor training is important.
Yep. Provide with all documentation.
Yep. If we pre-program the system, it ships out with the list of the program parameters that's already in the system. We also send out the CD that goes with it, and we always leave behind the installation and programming guide. So,
And just a side note, it does come with a CD. I know that 98% of you who would do this don't have a CD-ROM in your laptop. Shortly, it will be on our website that you can just download the software.
and if you needed to, we'll ship it out on a U.
Yeah, we can put it on a USB as
drive.
well.
Uh,
So just know that, yeah, we realize it's not technology that's used hardly anymore. So.
Again, training is really important to understand what the alarms mean and what you should do if you have an alarm. Calibration, everything is pre-calibrated from the factory, so we're not big on calibration at startup necessarily, but we do bump test the entire system. All gases detection systems should
Calibrated
be
per manufacturer recommendations.
Yep. So if you are going to do a yearly calibration, we have the calibration kits to do that with. They are kind of pricey, and it's difficult to ship calibration gas. It's costly to ship calibration gas, but absolutely, if you wanted to do field calibration of a sensor, we can help you with that as well.
Or if the engineer requires it,
Or
if it's required by code, certainly do it. But as we said, in most cases, just
bump test.
bump test them and then plan to replace them within 5 years.
And the life of the sensor is very much dependent on the amount of gas. So if you're in an environment that has 20 parts per million almost all the time, this sensor's life is much shorter than it is if you evacuate it all the way down to zero. So a typical parking garage, the fans stop when cars are rolling in the morning at the start of work, and system starts up when they leave, and they don't typically run a whole lot during the day. But definitely want to replace those no more than every 5 years, and less if you're running in high concentrations.
Right. Okay. So just a quick point on saving money with these type of systems. Many factors should be considered. You can use ECM fan motors or VFDs. That will reduce energy costs. Minimum ventilation air requirements versus the need for emergency ventilation. So if you have a greater changeover situation, you can look at running minimum fans or running just natural
Smaller
ventilations or smaller fans. So there's a lot of things you can do there. Use of modulation upon call for ventilation due to CO or NO2. So you can modulate the fans, modulate the dampers or louvers, depending upon that. And then use of natural ventilation if possible to meet minimum requirements. Fans only used for emergency ventilation. So we see that actually more often now than we did in the past, and that is an open air, open side parking garage as an example, where the minimum requirements are met through the airflow, the natural ventilation, but there's not enough there to clear it out. So they'll have a fan that only runs if we have an alarm level, right? So lots of different ways to save money with these systems. It can be a green thing if you think about it and you design it well, right? Okay. So what type of gas detection sensor is typically used in an MRI room? What type of sensor? Anybody? Nice answer. Got an answer here in the studio, and it was helium. Okay. So all right. So real quick, we just want to go through the products real fast, just to clarify what everything is. Before we get to that, I want to answer Ricardo's question. Do you need to get out of the building when CO or CO2 alarms go off? NO2, I'm assuming, is what you meant.
CO2, the answer is no.
No. CO2 just probably means you're getting tired. So you maybe go outside to get some air. But as far as CO and NO2, if it's at alarm level and the alarm is going off, you should probably exit the building. That being said, we typically alarm at 25 parts per million. That's not going to kill you, but it will certainly make you not feel well. Especially
it's not going to make you feel poorly in 15 minutes.
Right, yeah.
That's extended time in the
Right.
gas. So
Right.
at 25 parts per million, it is not an emergency, but something needs to happen.
Right, exactly. And then as far as CO goes, that's that number. And then NO2, I would, not that you're going to know the difference in a system when the alarm's just going off, but if NO2 gets up to 5 parts per million, you want to get out of the building. So
open doors and windows.
Yeah.
And get out.
Leave things open when you go if you need to. So I hope that answers your question, Rodrigo. Ricardo. So sensor-wise, the sensor that we most commonly would use is a Q5 sensor. They are standalone or can be used with the control panel, wall mount or duct mount. There's a 3-line LCD display that tells you quite a bit of information. They are NEMA 4 enclosures. They do have removable terminal blocks to make it easier to wire them. They do have 3 built-in programmable relays and 1 0 to 10 output. And then virtually
Missing terminals. That's right there.
virtually any gas is available that you're going to come across. There's very few gases, actual gases that you're going to come across that aren't that you're not going to be able to use with this. And then it's just simple wiring and programming. There's not a lot to this in terms of tech being knowledgeable about it and wiring it up. So that's the sensor itself.
And along with the wiring, every job that we do comes with a AutoCAD as-built, drawing. It shows if you have 10 sensors, it shows the 10 sensors, and it shows how they wire to the panel, and it tells you what size wire to pull. Mm-hmm. All of that's already on the custom drawing that goes out with every single system.
Right. So the Q4C panel, 4 is in the name, 4 sensors. It's basically exactly the same. Internal relays, outputs, LCD display. This is a NEMA 4 enclosure as well.
Uses the same software.
Uses the same software. And the only other thing is, this one does have buttons. The refrigerant monitor doesn't. You have to use the magnet. Okay, so essentially, there you go. It's a very simple panel. Virtually the same panel, just smaller and in a little bit different enclosure. The M controller, which is what we've been talking about the most, it's most commonly used. I'd say 80% of the jobs we use
at least, yeah.
The really nice thing, one thing to think about with this one is that it is a NEMA 1 enclosure. So
which is good for most garages.
Most garages is fine, but it's a locking NEMA 1 enclosure versus a NEMA 4 enclosure. So there are concerns there if it is in an environment where it could get wet or it could get gunky. I don't know. What's the word?
Put it someplace else.
Put it someplace else if there's a concern about the environment it's in. This is a picture. Oh, Rand, you got a question?
The relays, are they fixed onto there? Can they be changed?
They are fixed relays.
The question was what type of relays are on the board itself?
And on the sensor.
And on the sensor?
They are not changeable.
Right.
I don't know if you can see it from where you're at. There's actually one here you can see, and then there's 2 more that are underneath this LCD display. I think they're rated at 5 amps, if I'm not mistaken.
I think that's right.
So we don't ever, when we design a system, we don't ever put 120 volts through them. You can, they're rated for it, but we always pull in a rib relay or something else.
Mechanical relay?
It is a mechanical, it's not a triac.
Right.
So, and it's Form C, meaning it has normally open and normally closed. So if you want to set the thing up so that if this panel loses power, the fans are wired to the normally closed contact, you can use that to start it, or you can do that at the relay at the motor starter or whatever. So in general, while you can bring 120 volts into it for the relays, we don't. We designed this whole panel to remain low voltage.
Right.
You're talking about like 24 volts?
24 volts.
Yeah, low voltage 24, right.
One more thing.
Yes.
Is there a transformer in there?
No.
There is not. Again,
Is there a transformer in the panel?
so
It has to be externally.
it has to be externally connected. We always include that when you ask us to help put together a system. We always include the transformer size for the number of sensors. As a matter of fact, on our control drawing, it has the math on there that shows how we got to the transformer size. It shows 6 of this sensor at 0.8 amps and 8 of these sensors at 0.8 amps and the panels at 0.4 amps or whatever it is. And so it shows you exactly what size the transformer needs to be. You power all the sensors out of the panel, and it has 4 channels for both communication and power, and they're individually fused. We've done a couple of jobs where we've exceeded the fuse ratings and we just don't run the power out of this panel. But again, everything we try to do, we try to keep low voltage here, keep the 120 volts out of it, set the transformer off at the power source and run your 18 or 16 gauge 2-conductor power wire over to here.
Those are standard glass fuses?
They are,
Yes, correct. Okay, so Q controller wise, this is the big one. Used sparingly, I guess I'd say, because it's just usually not necessary.
It's not cost effective most of the time.
Most of the time, yeah. Unless we got a really big job.
If you got over 120 sensors, it's the right choice.
Yeah, right. So touchscreen graphic display. This one does have the BACnet optional interface. It is simple and fast to set up with a laptop or with the touchscreen itself. As far as it goes with when we've set them up, just the touchscreen makes it super easy.
The touchscreen makes you don't
Yeah.
even need the
You don't-
software
you don't-
on that one.
yeah,
On
it's-
the other
it's-
hand, the
it's
two
there.
little guys, software is
Right.
the recommended choice.
And that is an EMA 4 enclosure, so it can be in a environment where you would need an EMA 4 enclosure. And then the last thing to talk about here is the difference. So let me put it to you this way and be as blunt and simple as I can. There are many manufacturers of gas detection products out there. Probably the most well-known name being Honeywell Analytics, but there are many others.
We saw Honeywell.
We
Analytics
offer
too,
Honeywell
when
as
we're
well.
forced to.
When we're forced to. But as far as Honeywell Analytics goes, or any of the other manufacturers out there, one of the key things that has allowed us to be successful with this and allowed us to provide a great product and a great service with it is the fact that we, as a company, will provide custom wiring diagrams for the job. There's a small example there you can see
Tough
on
to
the
see,
screen.
but-
It's kind of tough to see, but we will provide essentially a controls diagram of this system that perfectly lays out exactly what you need to do to install it. We will engineer it if we need to do that. And as an example, Joe was talking about sizing transformers and things. We show all of that on that CAD drawing that we provide for you. And then we will custom program every panel from when we ship it, unless we're going to do startup. If we're going to do startup for you, we'll just come and we'll take care of it when we get there. But if small job, simple job, 4 sensors or 12 sensors, we'll program the system for you and ship it out ready to go, plug and play, and it's set up. And then
with test gas.
with bump gas, so that you can make sure that they're working. And then we will do on-site startup for you if there's a cost to it, but we will gladly fly out to wherever you are and do startup. Joe does enjoy a little bit of travel every now and then, and recently you were in Dallas, you were in
Probably
Florida.
4 or 5 stops in Dallas in the last couple of months.
Right. Yep. So he'll go anywhere and do your startup for you. There is a cost to it, of course. And then the last thing is the big difference for us is we have local reps with specified controls that you can go to in your area that are knowledgeable about this product, who will help you with this, and they'll also help package this with fans and louvers and all that and give you a complete package. So you can go to a local rep of ours for specified controls. As an example, I'll just give you, if you're in Florida, Stan Weaver and company will gladly help you with this. If you're in Texas, if you're in Dallas, ADW, if you're in South Texas, Texas Air Products, as an example, if you're in anywhere in the Pacific Northwest, the guys from Long Building Technologies will happily help you with this, and we will be involved in that entire process. So we do have local reps you can go to as well, and we're always happy to help with that process. So the big difference here is the service piece that we offer on top of the product itself. It's not just, here's your sensors, figure it out, good luck. It's, here's all the tools to let you be successful in installing this system and getting it to work, right? So that's the key difference between the specified controls options and the other manufacturers out there, or even the manufacturer reps out there in your local area that might provide another gas detection system. I have yet to come across one across the country that will do what we do to make sure that you're going to be successful as a contractor in doing this.
And it's life safety, so
yep, absolutely.
You don't want to guess.
Yep, exactly. So I think that's it. We've covered gas detection from a let's say it's not a 20,000 foot, but maybe like a 5.
Yeah,
like a 5,000 foot range. There are intricacies to gas detection. There are specific things that you might come across, but we're here to help you with that. And so are the Specified Controls local reps. They're there to help you with those problems, and we can get that taken care of for you. So we ask only that moving forward, if you need a gas detection quote, that you provide the plans, if there are plans, to us so that we can properly provide the right system for you. One of the biggest problems that we have is often, I don't have any plans, or I don't know what it's going into that system, and we have to play a lot of guesswork. Gas detection systems can go from very, very large to very, very small very quickly, depending upon a lot of factors. As an example, got a quote request the other day, and what I got was, it's 800,000 square cubic feet. Well, that's not a thing. And on top of that, it wasn't actually 800,000 square feet. It was 800,000 cubic feet, which actually equated to much, much, much smaller facility. So instead of it being, if it was 800,000 square feet, we would have had to have about 100 sensors. Now it's much smaller and it needs 9. Huge difference in cost between 100 sensors and 9. So anytime you can provide us with more information, we can provide you with a more accurate quote.
We don't mind throwing out budgets on
Right.
square feet. That's not
Right.
a problem, but it's not going to be accurate, especially if you happen to need 33 sensors.
Right.
All of a sudden, you're either buying another panel or a bigger panel, and so the more information we have, the more accurate we'll be, and
Right.
the better job we'll do for you.
And then the last thing I'll just throw out, again, we mentioned this, but replacement sensors. This is an important thing to know. Do not have to replace the entire sensor. There's a small piece here.
Just unplugs.
You just unplug. There's 2 screws, and it unplugs, and you can replace this. That is a considerably less expensive way of doing it than replacing the entire sensor. And there will come the need to replace these because they are consumable. They are not a product that will last forever, and that actually becomes a service piece for most contractors, where they have to, they go back and test them.
And you should go back and
replace
test
them.
the
You should.
system at least once a year.
Right.
With bump gas, make sure the fans and everything work.
Sure. So, are there any questions? We answered a lot of them already, but if there are any questions, now's the time. We'll be hanging out for a few more minutes, and we'll be glad to answer them. So we thank you for joining us, and just remember that Jackson Systems does training usually every week or every other week, and we're happy to have you sign up and join us online or in person. And moving forward, Tyler, what's the next training? Next week is Ecobee, who was the first Wi-Fi thermostat. And they make a great product. And are they going to talk about the new one, or maybe we don't know? I know they have a new one coming. They have the Ecobee 5 coming. So a new product that they're pretty excited about. If you're not familiar with Ecobee or Ecobee, they make a Wi-Fi thermostat that has Alexa already in it. So you can talk right to it and tell it to play music and do all kinds of craziness, and it'll do it. Great if you do not have teenagers. So join us for Ecobee next week if you are interested in Wi-Fi thermostats. I have not seen any questions yet, so I'm assuming that Joe and I are geniuses and have provided you with every bit of information you would ever need on gas detection.
I think you're confused.
And the POs will start in about 5 minutes, Joe. They're coming. All right, we're going to be selling a lot of gas detection because we just learned everybody about it.
You already do sell a bunch.
So, folks, we'll go ahead and shut it down unless we have a couple of more questions. Okay. So the producer has just told me that we're going to end it. So thanks so much for joining us.
Thank you.
We hope to see you next week.